So for problem 4, the slackliner. This is clearly a dynamics problem. It's actually statics because the acceleration is 0. We have a whole bunch of forces. We know that it's in equilibrium. So we can immediately say the vector sum of the forces at this point is equal to mass times acceleration is equal to 0. And now this is the only force we know. This is 500 newtons. But this is in equilibrium because these two tensions have a vertical component. This problem is expertly solved in your textbook. Please see it. But we can solve these problems by adding these forces, tension 1, tension 2, and the force of gravity. And although we don't know them, we know these angles. Because again, the ropes make a force that's in the same direction as the rope itself. Because the vertical component of this force plus the vertical component of this force has to equal the force of gravity. So that the force of gravity down plus the vertical components up is equal to 0. Or you could just say these guys split the force, each gets 250 newtons. And we recognize this ratio, 10 meters to 10 centimeters is 1 to 100. So this tension just has to be 25,000 newtons. What's 25,000 newtons? Well, it's the force of gravity on 2,500 kilograms, or about 5,000 pounds. If we were to model this as a spring, we could find the spring constant because the spring constant times delta x is equal to the force. And in this situation, the force of spring up must be equal to the force of gravity. So this is the force on the spring is 500 newtons. And so K is going to equal that force divided by delta x, which is just 5 times 10 to the third newtons per meter. And so if we model this as a spring, for sure, if we jump up and down, the higher we get, the more it will compress the spring, conserving energy. Right? Higher potential energy, higher kinetic energy, higher spring potential energy. That's going to stretch this more. Another way to look at it is when you bounce, and this comes down lower, at this point, it's no longer static. You're accelerating upward. Right? You come down, you're moving very fast, and it accelerates you upward. So this net force has to be in that direction. And so this number will go up. The tension on the rope has to get much greater so that the total force is then upward. And so that greater tension is also going to provide a greater horizontal force. It will be more likely to pull your car out of the mud.